The BQE in New York City is collapsing, and part of it has to do with how it was designed. So this part of the structure here is known as the triple cantilever, and as its name suggests, it's made up of 3 different shelves that jut out of the side of Brooklyn Heights. You have a lower shelf here for traffic, a middle shelf for traffic, and then you have the Brooklyn Promenade on the top. And the triple cantilever structure runs along this part of Brooklyn right here, and then you've got the promenade on the top floor over here. So I'm going to look at a cross section of BQE and take a slice of it right down the middle. And this is what that would look like. You have your lower cantilevering shelf here with traffic, your center one with traffic here, and then at the top you have the Brooklyn Promenade. When you load up the structure, it's going to be supported on piles down here and piles down here. And you're going to notice that it's going to deflect where you have a lot of bending in each of the shelves like this because it's the triple cantilever. And when concrete is stretched out, such as at the top of when it's bending, you're going to get cracks because concrete is naturally weak in tension or weak in that stretching motion. And because these are the locations where the concrete is stretching under its usual load, this is where the primary reinforcement is going to go. So most of your load-bearing reinforcement is going to run on the top of each of the sections here to hold the concrete together where it's trying to stretch apart. So with these rebars that I drew in here, you have a lot of your surface reinforcement as a lot of your really important reinforcement in this cantilevering structure. And it's also the same surfaces that see the most amount of load, whether it's from cars or people, but it also gets a lot of water moving across, which will also weaken the concrete and further the deterioration. This is made even worse by the winter conditions where you have a lot of ice and freeze thaw chipping away at the roadway, as well as a lot of salt water due to the salting of the roadway, potentially damaging the rebar. So after many cycles of this type of loading, you're going to get a lot of damage building up along this primary rebar that's basically holding up the entire structure. It would be one thing if it's damaging rebar on this face or on this face, but because a lot of the damage and wear and tear is happening right on here, it makes that damage a lot more serious when it does happen. I'm going back to this image here, you can see where a lot of the behavior of the triple cantilever really exposes this top layer of reinforcement here to a lot more damage. Now there are certain things that can be done to mitigate a lot of the damage. For example, another source of damage is overweight traffic, and because of overweight traffic sensors, a lot of that has reduced in the last few years. You can also reduce the amount of lanes that go across this part of the highway. For example, if you go from 3 to 2, then your rebar only has to carry 2 lanes worth amount of load, which means that its reduced capacity due to damage might be enough for the reduced traffic load. And there are talks to replace it and various proposals floating around, but it remains to be seen if the mayor's office will, get it together enough to actually put this into place before it needs to be shut down. But yeah, if you have any more questions, comment them down below or just let me know your thoughts on this.